In this lesson, we are going to discuss the least common multiple. Admittedly, this is going to be a little bit of a longer video simply because the least common multiple has many different uses. First of all, we know that you've done least common multiple before. We are going to review the two different ways of getting least common multiple of a number. We will review the list method, which most students prefer. We will also review the factor tree method. After that, we will see how you can get the least common multiple of monomials. And lastly, we're going to see how you can use the least common multiple to compare fractions, put them in order from smallest to greatest. A lot going on with this particular one, so we've got many objectives. Figure out how to get the least common multiple of numbers, figure out how to get the least common multiple of monomials, and then use it to compare fractions. All right, launching into that, first piece we have a multiple is a result from repeated addition. And of course, we'll see the examples coming up in just a moment. A common multiple occurs when you've got the same number show up on two or more lists of multiples. Even if you don't go through and create the list to find it, it would be there with the list created. The least common multiple is the smallest one of all common multiples. And lastly, least common denominator. You take the least common multiple of two or more denominators from a fraction. And I know without the examples, this is like, well, hooray, we've got a bunch of words. What good are they? Well, I don't want to take the time to put a bunch of examples here and then repeat examples coming up in a moment. So I'll wait for you to finish up. All right, now, with your earlier classes, I know that you've gone over how to create a list of multiples. And so this is intended more of just a quick, hey, you should remember type of thing. What are the multiples of 6? Okay, so we'd start with 6, and then repeatedly add 6 over and over and over. 6, 12, 18, 24, 30, 36. And essentially all we're doing is creating a row in a multiplication chart. Similarly, when we start taking the rows, the multiples of 14, 14 multiplied by 1, multiplied by 2, 14 multiplied by 3, multiplied by 4, multiplied by 5. And so all we're doing is creating a list, repeatedly adding the same number, or you could use multiplication. Well, looking at the list, we want to identify a number that is common to both. What number shows up on both? Well, right now we don't have one. Right now there's not a number that's common to both lists, and so we need to keep going. It's just a result that the list isn't long enough yet. Well, 36 plus 6 would give us 42, 48, 54, 60, and how about now? Do we have something that's common to both lists? Yeah. Yes, we have 42. With 42 on both lists, that's our least common multiple. This, of course, is called the list method. It's been my experience, most students prefer this because a lot of times they'll just write down copy down a row in the order of operation. Oh, that's insane. They'll copy down a row of a multiplication chart and then just look to see what shows up on both. However, in your earlier classes, you did go over a second method. A lot of times students don't remember it because, frankly, it's kind of more work. And so a lot of times students don't like this method. Nevertheless, we will need it, so we're going to go over it. Well, the second method is based on identifying your factors. So we'll create our prime factorization like we would get from a factor tree. 6 is equal to 2 times 3. 14 is equal to 2 times 7. In our earlier work, we then identified what the common factors were. For instance, what do they have in common for both lists? They have a common factor of 2. Earlier, we saw that the common factors, if you multiply them all out, that will give you the greatest common factor. We are going to be tied with that pretty closely because when you want to get the least common multiple of two numbers, you can always start by finding the greatest common factor that we were doing before, and then afterward, you multiply all that by the singles. And let me kind of explain what that means for us. We identified the common factor of 2. When we look at our results, this 3 is showing up on only a single line. That is, it did not get paired. It's not a common factor to both. Same thing with this 7. This 7 is showing up on only a single line. Those are what I mean by the singles. These unpaired numbers that are factors of one number but not both, those are also things that we have to multiply by. So when we multiply those, 2 times 3 equals 6. 6 times 7 equals 42. And we will observe we got the exact same answer. The least common multiple is 42. Most of the time, students don't like using this method because, well, it's longer. A lot of times it's more work than finding the least common multiple with lists. So a lot of times students don't remember it, which is kind of unfortunate because that's a tool that's really, really helpful for identifying the least common multiple when we start doing variables. And in fact, here's how we will take this approach. If we want to get the least common multiple, we will start by completely expanding it the same way that we did with greatest common factor. 6 equals 2 times 3 times x times y. Since 16 equals 4 times 4, we'll have 2 times 2 for the first 4, 2 times 2 for the second 4, then x squared. Completely expand them. From here, let's identify the greatest common factor. They have a 2 in common. We need that for our least common multiple. What else do they have in common? They have a pair of x's. We'll use that. What else do they have in common? Nothing. Alright, so with all the pairs used up, everything else is going to be a single. We need to use the unpaired 3, the unpaired y. We'll need all of these unpaired 2's, and then an unpaired single x. That stuff in the blue is our least common multiple. Not a very pretty format, so we want to clean it up. And so to clean it up, we'll take, what's 2 times 3? 6. Yeah, okay, 6. Over here, 2 times 2 times 2, that's 8. 6 times 8 gives us the number portion, 48. Putting on the variables, x multiplied by x, that's x squared. And then we still have a single y, so there we have it, 48x squared y. And we have our least common multiple. But even that is still kind of a lot of work, right? We'd like to have shortcuts. We'd like to find easier ways of doing things. For instance, when we were going over greatest common factor, we took advantage of some shortcuts. In particular, and let me write all this stuff out again because I'm backtracking. Okay? When we were going over greatest common factor, we didn't go through and say, well, let's find all the pairs. Eventually, what we did was say, let's just identify the greatest common factor of 6 and 16. Whether you do that with the list method or a factor tree method, find the greatest common factor. And the second part we did, recognizing that they both have this base of x, when we did greatest common factor, there was a shortcut to figure out what exponent to use. For greatest common factor, we just took the smaller exponent. Since 1 was smaller than 2, we would take the greatest common factor of just 1x. And you'll notice that's what we obtained here. There is a similar shortcut for least common multiple. And I wanted to mention both of the rules so that way you don't get them confused. You have to make sure that you don't get them backwards because backwards rules aren't going to work. Instead of taking the smaller exponent for least common multiple, we will take the larger exponent. Like before, you will still have to go through and get the least common multiple of the numbers. Whether you get that number with a list or you get it by prime factorization, that's entirely up to you. You will need to identify the least common multiple of numbers. From here, what is the larger exponent? It's a 2. When we compare x to the 1 versus x to the 2, the bigger exponent is 2, so we will simply take the larger exponent of 2. Similarly, we'll start looking at other variables. Here we have y, and what's the exponent on it? 1. If you do not see an exponent, it's understood that there is only one of them. But what about down here with 16x squared? How many y's are there? 0. And so this would be y to the 0 power because there are 0 of them there. In this context then, what's the larger exponent? Which is bigger, 0 or 1? So we'll take 1. And you'll notice our least common multiple matches what we already did before. We do have the ability to completely expand it. Take all the pairs, take all the singles. Completely valid, but usually more work. We'd like to be able to go through it more quickly. So, for number 1, what's the least common multiple of 8 and 18? Well, if we are using the list method, we have to start listing them out. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6, 8 times 7, 8 times 8, and there I'm up to 64. If we're using the list method, we got to start listing out our multiples of 18. So 18 times 1, 18 times 2, 18 times 3, 18 times 4, 18 times 5. I'm starting to run out of room, so let's stop there. What's our least common multiple? We don't have it yet. There's not one number that's showing up on both of those, so our lists are not long enough. We have to keep going. If we continued adding one more, 72, 8 more, 80. But we should recognize then that they do have the common 72, so least common multiple of 8 and 18 is 72. We're done with that one. That's the list method. If this is the way you prefer to do it, go ahead and do it the way you like. Our concern isn't so much on how you're doing it, it's about having the ability to find it whichever technique you prefer. Looking at question number 2, instead of creating 3 different lists, I just want to review the factor tree method. 4 is equal to 2 times 2. 5 as a prime number is just 5. And then 15 is equal to 3 times 5. So start by looking, what number do they all have in common? They don't have one. So their greatest common factor is 1 for all 3 of them. However, we can recognize that there is a pair of 5s. The 5 is getting used for 2 different rows. And that's the only one that's like a double that's showing up on 2 rows, 2 lists. And so we will take the 5 and we can multiply by each of the different singles then. 2, 2, and 3. When we multiply all of those out, we get our least common multiple. 5 times 2 is 10. 2 times 3 is 6. 10 times 6, we have our answer of 60, and we're done. If you wanted to do it with a list method, you're completely welcome to do it. I just wanted to quickly show both methods, that way you can choose the one that you like better. And the reason you get to choose, of course, is now we need the least common multiple of 12 and 18. Doesn't matter how you do it. What's the least common multiple for 12 and 18? Well, however you come up with it, you do need to recognize that the least common multiple is 36. Whether you choose to do a list or you choose to do a factor, that's up to you. Now we have to attach the variables. What variable shows up? X. Okay? Based on these, what is the larger exponent? 2. With a larger exponent of 2, we put on the 2, and we're done. 36x squared is our least common multiple. Now we'll go on to number 4. What's the least common multiple for 4 and 10? That would be 20. From here, we need to put on the variables. So what variables pop up?
X, Y, and Z.
We have x, we have y, we have z. All 3 of them are there. So we need to determine what variables get which exponent. What is the largest exponent we see, or the largest exponent we have for the x?
0.
X to the first, x to the first. Our largest exponent is 1, so we'll use just x to the first. What about the y variable? There's only one of them, so it's going to be y to the first. For the z variable, what's the biggest exponent on z's? That's 2. We'll put on a 2. That's our least common multiple. Get the least common multiple for the number part, and then for each variable, we need to take the largest exponent for that variable. Now, lastly, we want to be able to compare and order fractions or mixed numbers. In order to compare fractions, we absolutely have to have a common denominator. So the first step is to get the least common denominator. Well, this stuff only applies to fractions. Right here, we've got the mixed number 4 and 5/12. If we want to start comparing fractions or ordering fractions, we have to have fractions, not just mixed numbers. So the first thing we need to do is change this into a mixed number, or from a mixed number into an improper fraction. Do you remember how to change mixed numbers into fractions? First we multiply, then we add. 12 times 4 plus 5, that's 48 plus 5, which is 53. So now we're moving with the least common denominator of the fraction 53 over 12, the fraction 9 over 12, and the fraction 33 over 8. This is one place where the least common multiple comes into play. We have a denominator of 12, we have the denominator of 2, and the denominator of 8. To get the least common denominator, we need the least common multiple of those three numbers. So, what is the smallest number where all three of them fit? Well, do all three of them go into 12? No. 8 times 1 is 8. 8 times 2 is 16. 12 does not work. So we'll go to the next one. 24. 8 times 3 is 24, so that one works. 2 is going to go into 24 since it's an odd number, since it's an even number. So we would have to recognize that since the least common multiple is 24, the least common denominator that we need is also 24. In order to compare the fractions then, we're going to change all three of them so that they have a denominator of 24. Thus, we're creating that denominator of 24. To change the 12 into 24, what do you have to multiply by? 12 times 2 equals 24. So we have to multiply both the top and bottom by 2. 12 times 2 equals that 24. 53 times 2 equals 106. And now we have to continue. What would you multiply 2 by to create 12, to create 24? Two times 12 is 24, so multiplying both the top and bottom by 12, 9 times 12 equals 108. Similarly, 8 times 3 is 24. So 33 times 3 gives us 99. And what we wind up with then, we have the three fractions, 106 over 24, 108 over 24, and 99 over 24. That's relevant for us because now all we have to do is look at the numerators. Which is the smallest numerator? 99 is smaller than 106, and 106 is smaller than 108. Just putting the numerators in order, we get 99 over 24 is smaller than 106 over 24. 106 over 24 is smaller than 108 over 24. And all of those are things that we could then put in back into their original form. The 99 was originally 33 over 8. We want our answer to match the same format as the original problem. The middle number of 106, that came from 53 over 12. But remember, the 53 over 12 came from the mixed number 4 and 5/12. So we'll come back down and say 4 and 5/12. And then, of course, the last number of 108 came from 9 halves. And so we've got them in order 9 halves. It's worth noting there are other ways of putting them in order. We did it this method so that we could review comparing fractions. If we wanted to, we could have put all of these into mixed number format, and we could have just compared mixed numbers. That could have been easier. There is more than one way to do this. We were just reviewing this particular method. If you remember other ways of doing it, go ahead and use the ones that you're comfortable with. Use the methods, use the tools that you know well and that you're comfortable. If you know it, go ahead and use it.